A lot of times in our algebraic careers, we're going to see the variable appearing on both sides of an equation. What do we do there? Well, the exact same process as we did before. Isolate the unknown to one side and bring all the constants over to the other. Let's take a look at a couple of examples together. I want to actually begin by returning to an example that we saw in an earlier lecture where we actually did a lot of the algebra, but we actually didn't finish solving it. So it was sort of like an algebraic cliffhanger. And now we're going to finally solve it. So I'll actually review what we did very quickly and then now solve it. So here's the equation that we saw before. And now what we saw last time was that we can first distribute everywhere. Lots of distributing. And so we get the equivalent relationship. 3x plus 6 equals 10x plus 15 minus 30x. Then we can actually combine this side a little bit. I'll keep the left-hand side the same. 10x minus 30x we saw was negative 20x plus 15. And that's where we left the story a few lectures back. Well, now we can actually think about what we want to do here. Well, the first thing we want to do is bring all the x's to one side. So the way that I'm going to do that is to get rid of this minus 20x by adding 20x to both sides. By doing so, this would combine to give 0. But I've got to do it to both sides, and I've got to make sure I'm lining up the terms that are like. So when I do that, what do I see? Well, on this side, I see 3x and 20x is 23x plus 6. And on this side, I have this term canceling, which is by design, but I'm left with the 15. Now, if I pull this over to this side, I see 23x subtracting the 6 from both sides. By the way, one way of thinking about this is to think about physically taking the 6 and moving it to the other side, but changing the sign. In fact, that's how I think about it in my own head. I actually don't normally write minus 6 equals minus 6. That's just for you and I. But when I'm doing it by myself in the privacy of my own dorm room, I don't live in a dorm, but if I did, I would just bring this over to this side with a minus sign there. So if you get comfortable doing that, that's great. If not, that's fine too. 23x equals, and here I have 15 minus 6, which is 9. So if you want to now solve for x, I divide both sides by 23, and I see x equals 9 divided by 23. And again, you might enjoy checking by plugging that back in and verifying that, in fact, you get the same answer. I'll leave that to you to try. Let's try another question together. This one, why would anyone start a question with 4? Here's the one I want us to think about. A minus 2 plus 3 over 2 equals 3 over 2 times 1 minus a. Notice again, the unknown in this case is called a. That's okay, we're not afraid by that. Here I have an a minus 2, here I've got a 1 minus a. We can now go through and do the work. We could actually, if we wanted to, distribute this term and so forth and do it, and it'd be fine. It'd be great. But let me just tell you something about myself. So I'm going to get a little bit personal. I hate fractions. I know that we talked about fractions a lot together. We thought about them. We've added them. We subtracted them. We multiplied them. We divide them. I don't like them. I don't like them in my algebraic equations. I want them out. So we could actually do that, though. We could actually clear away the denominator by multiplying both sides through by the same number that would actually get rid of the bottom. In this case, if I just multiply everything through by 2, so if I multiply this side by 2, then I have to multiply this side by 2, so it doesn't change the balance. And now notice what happens. Now here, by the way, there's some distributing stuff that's got to go on. I got to distribute to that term and to that term. But look what happens. Well, here I have 2 times the quantity a minus 2. And here, when I multiply the 3 halves by the 2, I have a cancellation, and I'm just left with a 3 on the top. And that now equals the 2's cancel here, and I'm left with this. Well, this is just great, because now the fractions are gone. Look, if you love fractions, then by all means, keep them in, and please don't be offended by my hostility toward them. But if you're like me and don't want to worry about fractions, multiply through by a big enough factor to clear off any pesky denominators that you may see. Now, we've got a question that we can now do. How do we proceed? Well, we'll distribute. Get rid of the parentheses. That's always the first step. So here I would see 2a minus 4, then here's the plus 3, equals 3 minus 3a. How would you proceed now? There are lots of ways. There's no one next correct step. For example, you could take the minus 4 and the plus 3 and combine them to get a minus 1. I'll do it that way, but you might not have done it that way. It's okay. There are a lot of roads that lead to the correct answer. You follow the one that's right for you. Now, you might want to bring that minus 3a to the other side by adding it, or equivalently, by adding 3a to both sides, keeping the balance of power. And here we'd see 5a, 2a plus 3a is 5a. Don't forget your minus 1 is dangling. These cancel, I'm left with a 3. I can now add 1 to both sides, and I see that 5a equals 4. And so if I now solve for a, I see a equals 4 over 5. And again, you can see if this is right by plugging that fraction in for a and checking that this, in fact, is an equality. I'll let you try that, see if I'm right or not, and I'll see you at the next lecture.